In this problem, we will calculate the specific heat of a metal using calorimetry data. It's often helpful to draw a picture because in calorimetry problems there are a lot of measurements to keep track of. Let's organize the data before we start the problem. First, we have a calorimeter full of 75 grams of water, and the initial temperature of the water is 24 degrees Celsius. We have a 92.9 gram piece of metal, and its initial temperature is 178 degrees Celsius. We know that the metal will transfer some of its heat to the water, causing the temperature of the metal to decrease and the temperature of the water to increase until thermal equilibrium is reached, and that temperature we know is 29.7 degrees Celsius, and that must be the final temperature of both the water and the metal. Now we're ready to start the problem. We need an equation that will relate the amount of heat the metal loses to the amount of heat the water will gain. And we will use the law of conservation of energy to help us with that. So we know that the metal will lose heat and will be exothermic, and all of the heat that the metal loses must be absorbed by the water, which will be endothermic. Remember the equation that allows us to calculate heat from specific heat, mass, and temperature data. I'm going to put that over here for us to reference. Now we can plug in that equation for Q. So we will have the specific heat of the metal times the mass of the metal times the change in temperature for the metal on the left side of the equation, which will equal the specific heat of water times the mass of water times the change in temperature for the water. Now let's start plugging in some numbers into our equation. We don't know what the specific heat of the metal is, so we'll leave that as an unknown variable. We know the mass of the metal is 92.9 grams. The change in temperature for the metal is the final temperature minus the initial temperature. And on the opposite side, we have specific heat of water given in the problem as 4.184 joules per gram degrees Celsius. The mass of water is 75 grams, and the change in temperature for the water is final temperature minus initial temperature. If I simplify my equation, I will get on the left side specific heat of the metal times 13777.07. And on the right side, I will get 1788.66. And solving for S metal will give us 0.130 joules per gram degrees Celsius as the specific heat of our metal.